Now we are going to talk about interfaces. In this simulation, remember that we have foxes and rabbits and ants and hunters and things that act in some way, like ants and foxes and rabbits. Originally inherited from actor, but once we had drawable as a superclass, we then made actor an interface. So this is what the actor interface looks like. Instead of saying public class and the name, it says public interface and the name of the identifier for the object. Sorry, the name of the identifier for this interface. And it contains the signatures for two methods, but no implementations for them. And then also comments describing those two methods. So it looks a lot like an abstract class that has only abstract methods as well as not having any instance variables. We also don't need to use the keyword abstract because all methods specified by an interface are abstract. So then it just looks like this: public interface actor and the signature of each of the methods that anyone who implements actor is promising to implement. So then, when classes are going to promise to implement an interface or promise to conform with it, we say that they implement the interface. So this is what fox and hunter look like in their declarations. Public class fox extends animal because fox has animal as a superclass. Fox is a animal, and then it also implements drawable because drawable is an interface. Similarly, public class hunter implements actor and drawable and is not an animal. So what this means then is fox is a subclass of animal that also promises to do everything specified in the drawable interface. Likewise, hunter promises to do everything in the actor interface and the drawable interface, but is not a subclass of any other classes. Even though when a class implements another class, or when a class implements an interface, it does not inherit any code, it is still the case that all of the classes that implement that interface are considered subtypes of the interface type. So this means that polymorphism is available with interfaces as well as classes. In other words, we can, for example, have a collection of drawable objects and use a for each loop to step through them and call the draw method, or a collection of actor objects, which indeed the simulator has, and step through those and call the act method. So even though the interface does not define an actual supertype, does not define an actual superclass, we can still consider it a type. So in interfaces, all methods are abstract. There are no constructors. All methods are public, and all fields are public, static, and final. So while there can't actually be instance variables in an interface, you can have public, static, final fields, which, remember, means fields that declare constants. We can think of an interface as a specification rather than an actual thing that contains an implementation. Or another way we might term it is to think of an interface as a contract. Anything that implements drawable agrees to meet the drawable contract. Anything that implements actor agrees to implement the actor contract. So in an interface, there's a very strong separation of the functionality from the implementation. Now, it is still the case that both the parameter types and the return types are mandated because that is necessary so that we can have polymorphism over the interface type. So the way that a client interacts with the thing in an interface is independent of the implementation, in the sense that the client can call the interface without needing to know anything about how this particular implementation of it works. It also means that clients can choose from alternative implementations when one may be more suitable for it than another. We can also think of an interface as a contract, while a class represents the is-a relationship, or a superclass represents the is-a relationship. Another way we can think of this to contrast them from classes is to think of a class as like a skeleton versus an interface, which is merely a contract. So a skeleton is something you can build on to make something, whereas a contract is merely something that some entity that you sign the contract with in the real world promises to perform. So then, interfaces provide specification without implementation. Interfaces are fully abstract. They can contain no implementation, though they do contain the declaration and definition of constants, potentially. Interfaces support polymorphism because we can treat an interface as a type. And Java interfaces are the provision in Java for multiple inheritance. So when we're using interfaces, we can have multiple inheritance via the interfaces, even though there is not multiple inheritance over the actual is-a relationship or the superclass relationship.